Okay, welcome back. The last couple of models that we have drawn in this series have been a plane vertical, which I'm looking at now, and then we did some raised verticals. Now, I just want to say that I normally compare my models at 5 degrees off the horizon. There's a reason for that, and I'm sure I did a video about it. But so if we just benchmark this at 5 degrees off the horizon, you will see that with my current ground, it says minus 5.7. All right, I'm going to make a note of that on my little book here, minus 5.7 dBi. And there's a reason for that, and we'll come to it in a minute. But interestingly enough, while we're just here, we can change the ground setup to, by the sea, 5,000 millisiemens per meter. And we're right on the ocean, okay? Radials aren't in the ocean. The radials are on the beach, okay? And you will see this changes now. So 5 degrees off the horizon, now I'm at 4.1, okay, which I will just put in blue, because that's by the sea. 4.1 dBi. By the ocean. Interesting, isn't it? But today is delta loops. So we'll do File, New. We'll get a clean piece of paper, and we are going to do a horizontally delta loop. So horizontal delta loop looks like this. It's lying flat on the ground, and we will have generally a 4:1 balun here, and that will make a multi-band antenna if we build that, say, for 40 meters. Each of these length is about 13 meters, 14 meters long. It doesn't have to be super accurate, but the more accurate you can get it, the more fun you can have with it. So I'm going to head straight into the wire edit button, and we're currently on the XY, okay, which means we're looking straight down on this. And I'm going to click this button here, which is a new wire. And I'm just going to do a test line that's 20 meters. That's actually quite long. So I'm going to zoom in now. We haven't used the zoom function before. Zoom into there. And I'm going to draw another line. And just make it look delta loop-ish. And then we'll do some adjustments. So these are far too long. So I can grab and hold and bring back to there. Now you could do some maths before this and work out 18, 17. So we're heading in the right direction. You will see that all these stay connected to each other as we move them around. 14, 14. So let's take this, bring it to there. And also we're slightly offset from the very center. We could go slightly to the left. In fact, I'll just do that now, just to keep the maths happy inside the little brain in here. All right, 13.8 there, 14 there, that's fine. I would think you would agree, as a delta loop, we're going to put our feed point and balun here. Okay, so we'll show you how to change the impedance there. So there's the geometry, 3 wires, okay? There's the view tab. If we take wire 3, wire 3, I don't know, end or beginning. Let's see if we're lucky. Ah, it's there. So we've got the source in the right place. Now we can go to the calculate button. This is for 40 meters. So back to geometry, 7.2, give or take. All right, there it is there. 7.2, it says it now. Real world, and we'll give it some height. So we're going to give it 10 meters. Well, it's a model, isn't it? We're not actually building it. 10 meters height. However, it's going to try and match it to 50 ohms, and we are somewhere between 170 and 220 ohms. So we click the optimization button. This is to fit a 4:1 balun. We click advanced. We go to the environment tab. It might come to goal. Environment tab, and we put in 200 ohms, which is a 4:1 balun. Then we hit cancel, by the way. It's remembered it because I think, yes, this, you can see in the middle left of the screen, SWR is 200. And it's saying that our impedance is, our SWR is 2.36, probably because we're not, we're on the wrong size. We need to change the size, okay? So I've clicked the plots button, SWR, resonance. And it says we're good for about 7.5 megahertz. If you remember the trick I used previously, we go back to the geometry tab. I put in 7.5 here, and I force it up to 7.2 by using the wire scale. 7.2, and everything will change, and we'll end up with a tape measure that requires about 16 digits. So I'm doing edit, round value, just 3 digits, say. And there it is there. Right, we could actually measure that now with a tape measure. So we're accurate to the millimeter, which is about, I don't know, 1/16 of an inch or something. Now we're on 7.2. And we hit the calculate button, and that's a much better SWR for our little transistor radio. And there is our far field plot, okay, 10 meters off the ground. Our vertical has still been saved, by the way, so we could compare that to our vertical, and we can see from the azimuth profile and the elevation profile that the vertical will be beating it for the lower angles. Oh, and that's what we know, isn't it? Just before I go, we can do 14.3 because delta loops are resonant on every frequency, and that goes up and up until, let's say, I don't know, 28.5. Bit of fun. And you can just start to see a pattern forming here. Far field plot again to 3D. And there's our far field plot. And just to satisfy you, tools compare, load the vertical in, and make your mind up. Good. All right, next one, we're going to convert this into a vertically polarized delta loop. All right, so enjoy your radio, keep playing with the software, and I'll see you on the next one. Whoops, all the best now.